All right, should be starting just a second. There we go. Okay. So I'm going to share my screen and pull up our course. Okay, so, oh, wrong course. Okay, let's go to Math V40. There it is. Okay, so we're at the very end of chapter 3. So remember, chapter 3 is on logic, and we've been kind of building our way up. We're finally at kind of the culmination where we're going to take an entire argument and we're going to plug it into truth tables to determine, hold on, let me turn off my notifications, to determine the argument's validity. Okay, so I'm going to open this up and we'll go right from the text here. Of course, you guys can have, click on the videos if you want, but I'll walk you through the main stuff. Okay, great, Noah. Just saw your comment there. Okay. All right. So you guys can read this on your own, but I thought maybe, some people are more uh, uh, audible learners. So maybe that'll help. So, in the last section in 3.5, we've already handled analyzing arguments. Remember, an argument is basically when you have some, maybe 1 or 2, 3, 4 premises, and then you have that horizontal line, and then you have your conclusion statement at the bottom. When you're working with premises that have the word all, some, or no, these are the quantifiers, right? You have the universal ones, all and no, and you have the existential ones, some. So in those situations, we use Euler diagrams in general to analyze the arguments, but not all arguments have these words in them, all, some, or no. So for these more general case of arguments, we're actually just going to use truth tables like we normally do. Okay, so we'll jump right into one and see what you think. So we're going to determine whether the following argument is valid or invalid. In order for an argument to be valid, what must happen is at the very end of our truth table, basically we have to have a row or a column where everything is true. That makes it a tautology. That makes it a true argument. So let's take a look at this guy. We've got 2 premises. The first premise is if the tank is empty, then I must fill it. That's a conditional statement. Do you guys see it? Do you see the if and then the then? If, then. Okay, so you could write this in words. If you let P represent the tank is empty, which is this part right here, and you let Q represent the statement I must fill it, then we can write the first premise like this. P implies Q. Is that okay, Tanya and Doolin? Or Tanya and Noah?
Yes.
Okay, all right. All right. So the second premise that's given, this is above the horizontal line, says the tank is empty. And that's the statement P, right? Okay, so you have 2 premises. You have P implies Q, and the second premise is just the single statement P. Now, below that, we have our conclusion, and our conclusion in this case is Q. I must fill it, right? It's the same conclusion over here. So this is what the entire argument looks like in words, and this is what the argument looks like in symbols. Is that okay?
Yes.
Okay. Now, in order for this to be a valid argument, essentially what we're saying is that if this premise is true and this premise is true, then this must be true. Now, think about what I just said. I used the word and I used a then in there. This must be true. So if this is true, So there's one of the premises, and the second premise is true. So see the and statement there, the and connective, and then P. If both of these are true, so if both of these are true, notice the if, and then the conclusion must be true. So you can see that I'm making an if-then statement. The if, everything that follows the if is the premises, and then there's a then, and then the conclusion follows the then. Okay, so what I've done is I've taken this argument, which is in symbols. It's written kind of in this um, row format, and I've rewritten it as in a logical statement. And what we're going to do is analyze the truth table for this entire statement right there. Do you guys follow that so far?
Yeah. Yes.
Okay. All right. So this is actually nothing new. I mean, we're just going to find the truth value of this guy. So what you want to do is build your way up. Okay, so you can see that at its core, there's only two statements. There's a P statement and a Q statement. So over on the left, what you do is you write down all possibilities for P and Q. True, 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 false, false, true, and false, false. This is given. You don't have to figure those out. You just plug in all possibilities. Now, in order to get to this entire statement, you want to build your way up. So I can see that I'm going to need a P implies Q. So I'll write a P implies Q column. I'm going to need P implies Q and P. So that'll be my next column. And then my final column, the one that I'm after, is going to be the entire statement, which is P implies Q and P, all implies Q. You guys follow this?
No, the um, all of it is because it's in the brackets, right?
Oh, right here? Yeah.
You do what's in parentheses first,
Yeah.
and then what's in the brackets,
Yeah.
and then the last, right?
Yeah, you do all the grouping. So parentheses is a grouping symbol. So we'll do P implies Q because that's the innermost grouping. The next outer grouping is P implies Q and P. So that would be that one right there. So this one first and then that one.
Okay.
By the way, you kind of have to build up to get to this one, right? You need the P implies Q first in order to do this one.
Yes.
That one first. Okay, so the rest is pretty straightforward as long as you were able to get through, what is that, section 3.3 and 3.4. So you just analyze the truth value. So we all know that P implies Q is almost always true, except for when the antecedent is true and the consequent is false. So we have true, 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 and the only one that's false is right there. Is that okay?
Yes.
Okay, so next we have P implies Q and P. Okay, so the P implies Q column is this column right here. And the P column is this column. And we're doing an and. Okay, so for an and statement to be true, both uh, both components must be true. So we have a true here and a true here, so that's true. Here we have a false and a true, so that's false. Here we have a true and a false, so that's false. And here we have a true and a false, so that's false. With an and statement, the only way to get a true is if both components are true. It's almost always false. Does that make sense?
Yes.
Okay, finally, for the ending, we're going to do the entire statement now. This is the argument, right? There's the first premise, there's the second premise. We put an and between them, and then it implies, and then our conclusion, which is Q. So this is now our antecedent. That's this column here. That's our antecedent. And then Q is going to be our consequent, which is this one. And it's an imply statement. So we know for imply statements, these are always true except for when the antecedent is false and the consequent is true. So what we do is we look at this row, I'm sorry, this column, and this column. So we have true implies true, that's true. False implies false, that's also true. False implies true, that's also true. And false implies false, that's also true. All right, so now what can we say? Well, if you get a column where everything is true, that's called a tautology. And that means that this argument right here, this argument is a good argument. Okay. Now, you might want to think about the argument. It kind of makes sense. If the tank is empty, then I must fill it. The tank is empty, therefore I must fill it, right? This one kind of makes sense. It's almost obvious why this makes sense with English words, but what we're doing is translating everything into symbols and then writing its equivalent, writing the argument as a complete statement using and implies, and then checking to see whether it's a tautology or not. And if it's a tautology, then it's a valid argument. Do you follow that?
Yes.
Okay. All right. So that's pretty much the point of this section. Um, uh, I don't need you to memorize this name, but when you have an argument with the first premise P implies Q and the second premise P, the conclusion must be Q. We just proved that in the last argument. This is called modus ponens or the law of detachment, but don't worry about that. All right, here's the steps to kind of work through it, but hopefully you guys can kind of figure it out as we go. You don't need to memorize these. It's pretty straightforward. So let's take a look at another one. We're going to determine whether the following argument is valid or invalid. How many premises do you see here?
One
Wait,
or what did you? Oh, two. Sorry, I thought you said parentheses for some reason.
oh, yeah, premises. Sorry, it sounds like parentheses. Yeah,
Two.
you have one here and you have one there, and then your conclusion is below the line. So what you want to do is, um, write it in symbols. So what we can do is let P represent our guests arrive before lunch, and let Q represent we'll eat out. And then you can translate this entire argument into this symbolic argument. So you have P implies Q, and then the second premise translates as Q, and the conclusion is P. Is that okay?
Yes.
Okay, so the rest is pretty much the same. What you want to do is you want to take to make this into a one entire statement, you're going to take the P implies Q, and you're going to write a conjunction with Q. So it's P implies Q and Q. So there's the premises. And then you write implies, and then the conclusion goes after the implies. And then all you have to do now is fill in the truth table. Okay, so what you want to do is work your way up. You're going to need P implies Q, so you need that column. You're going to need P implies Q and Q. You're going to need that column. And then you're going to need the entire thing, which would be the last column. Okay, and as you do this one, remember the first two columns are given. You just write down all possibilities for P and Q. The rest, you're going to use what you know about the connectives. So P implies Q would be true, false, true, true. And it's okay if you don't remember these as fast as I do. I've been doing this for a while, so don't worry about that. You'll get it as you go. P implies Q and Q means that both components have to be true. So this would be true, false, true, and false. I'm looking at this column and this column. So true, true, and true, true. And then for the implication here, the conditional, conditionals are almost always true except for when the antecedent is true and the consequent is false. So this is the antecedent. Let's see, true, 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 false. So this is the only one that's false. Now, is this a tautology or not?
No.
No, yeah. In order to be a tautology, it has to be true all the way down. So what that means is this is an invalid argument. It's not a good argument. If you had a friend make this argument to you, you could tell the friend, hey, you made an invalid argument. It's actually called the fallacy of the converse. Um, so if our guests arrive before lunch, we'll eat out. We ate out. And a lot of people think that that would mean that our guests arrived before lunch. And you're using the converse, which you can't do. So it's a little hard to sort this out in English, but if you write it in symbols like this, and then you use your knowledge of truth tables, you can actually prove it to someone that understands some basic logic. Okay, is that okay?
Yes.
Okay, all right, let's keep going here. All right. Yeah, there's a couple other ones with reasoning similar. There's also the fallacy of the inverse that looks like that. This will not yield a tautology. I think this is one of those. Yeah, this is the fallacy of the inverse. So let's take this one. If I can avoid sweets, then I can avoid the dentist. You'll notice that the word then isn't in there, but you can see the word if, and if you put in a then, it doesn't change its meaning. So this is an if-then statement. So we could write the first statement as P implies Q. And the second, I could say premise, sorry, the first premise. And we could write this premise as not Q. Do you see why it's not Q?
Yes, I see.
Because you can't avoid the dentist, right? So that's different. And the conclusion is I can't avoid sweets. So that would be not P. So what we do is we just run through the logic. We want to translate this as an entire statement. We write P implies Q, and then the connective and then not Q, and then implies not P. And then we just create the truth table and we analyze the argument. And in this case, we do get all truths all the way down. So that means that this is a valid argument. This is a great example of one that's kind of hard to understand if you were trying to figure this out in English. But if you translate it to symbols, you can see that it's definitely true. And this one's called modus tollens, or the law of contraposition. Is that okay?
Yes.
I won't walk through filling in the table because I think you guys can do that at this point. You might make some mistakes, but that's okay. You'll figure it out as you go. Here's another one. Determine whether this argument is valid or invalid. I'll buy a car or I'll buy a vacation. I'll take a vacation. I won't buy a car. The conclusion is I'll take a vacation. So this one, there is no if-then statement. That's an or statement, the first premise. So we would write this as P or Q. And the second statement is I won't buy a car, so that's not P. And the conclusion is I'll take a vacation, which is Q. So to translate this into an entire statement, you would write P or Q right there. That's the first premise. And then you'd put an and then your second premise goes right after that. And then you write implies, and then you put your conclusion right after. So all these are done the same way. It's not that, like I was saying, it's not too bad of a section. It's more complicated because you're going to have more complicated statements. They're going to be longer, but it's really nothing too much new. So for example, on this one, when you create the truth table, you do end up getting a tautology, and we call this the law of disjunctive syllogism. I don't need you to remember that name though. That okay?
Yes.
Okay, any questions from you, Noah?
No, I'm all good. Thank you.
Okay, all right, great. All right, here's another one. If it squeaks, then I need WD-40. Do you guys know what WD-40 is?
Yes.
Yes.
Okay, all right, good. Just in case. So that's an if-then statement. And then here's another if-then statement. If I need WD-40, then I must go to the hardware store. And then the conclusion is, if it squeaks, then I must go to the hardware store. So you'll notice we have an if then, we have an if then, but you can see that we actually have three core statements. The first statement, P, is it squeaks. And then we'll let Q represent the statement, I need WD-40. So the first premise can be translated as P implies Q. For the second premise, this would be P implies, and then we're going to need another letter here. We'll let R represent I must go to the hardware store. So the second premise can be represented as Q implies R. We put a line underneath, and then here's our conclusion. This is another if-then statement. If it squeaks, then I must go to the hardware store. So that would be P implies R. So we're going to set this up the same way. You're going to take your two premises and you're going to put an and between them. And then for your conclusion, you put an arrow and then you put your conclusion afterwards. So it's no different. It's a little more complicated, but you're really doing the same thing. All right, now because we have three core statements, we have P, Q, and R. Over on the left, you want to make sure to write those down, and you want to write down every possible combination. So there's really nothing to figure out here. You just have to write down all the combinations. So one of them would be true, 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 and then true, false, true, and then true, false. I'm sorry, true, true, false, true, false, true, true, false, false, and then false, true, true, false, true, false, 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 true, and false, false, false. Anyways, it doesn't have to be in this order, but you do need to go through all possibilities, and there's going to be 8 possibilities. And then what we do is we build our way up. Remember, our goal is to get to this, and that's going to be the one on the far right. That's going to be let me exit out of there. Oops, that's going to be this guy right here. So you want to do all the little parts first. So you're going to need a P implies Q. You're going to need a Q implies R. You're going to need a P implies R. You're going to need a P implies Q and Q implies R. That's on the left. And then you can do the entire statement right there. So I'll let you guys do this one on your own. You guys know enough about conditionals to fill in the table. I think maybe the tricky part is knowing how to build up to get to this one. But, just kind of think about it. What are all the parts you need? You need a P implies Q, so write it down. You need a Q implies R, so write that down. You're also going to need the and, both statements together with an and. So write that down somewhere. It doesn't have to be, at the beginning. It could be over here. And you're also going to need a P implies R. So you notice I have all the components here. And then you're also going to need the entire statement. And you can see in this case, all the truth values, they're all true. So this is a tautology. And this kind of argument is called reasoning by transitivity, or the law of hypothetical syllogism. And again, I don't need you to remember the name, but that is what it is. Okay, so if you wanted to remember the names, I don't think I asked you for the names, but if it does come up in your homework, it's pretty straightforward. These are the ones that we've studied. These are all valid arguments. These are the ones that yield tautologies. Okay, we've gone through each of these today. So I think, is there more? Let's see. Oh, yeah, and here's some invalid arguments. There's the fallacy of the converse, which we went over. This does not yield a tautology. And the fallacy of the inverse, this also does not yield a tautology. Okay, and here's a longer one for a challenge. By the way, when you're working through this textbook, make sure you pay attention. They have examples here. Sometimes they'll have videos. If you go back, let me go back just to show you, because you guys are able to learn this on your own. If you wanted to, here's the video right there. If you click there, there's a video on this section. If you ever get lost or something, or want to review something, it's good to use those. Okay, So this one, hopefully you can see the argument here. They don't actually draw the line, but hopefully you can see it. This would be the first premise. This would be the second premise. This would be the third. This has three premises. And then therefore, and this would be the conclusion. So it's the same idea. In this case, you have three core statements. You have P, which represents Eddie goes to town. You have Q, which represents Mabel stays at home. And then you're also going to need an R, which is readable cook. So when you translate these, you're going to have a conditional, another conditional that starts with a not Q. The third premise is not R. And then you draw the line underneath. And then your conclusion is not P. Okay. So you can see it's getting a little more complicated just because there's a lot of parts. But if you think about it, it's the same thing. It's just requires a few more parts to build up. So if you're able to do the last couple problems, you can definitely do this one. It just requires a little more work. So what you want to do is write down the entire argument and then write down all the parts you're going to need. So you want to build your way up to this. So I'm going to need a P implies Q. I'm also going to need a not Q. I'm going to need a not Q implies R. I'm going to need a not R. So you can see there they are right there. I'm going to need the entire left-hand side. I've got three ands together. And then I'm going to need the a not P, and then I'm going to need the entire statement here. By the way, we haven't really worked with I said three ands. There's two ands, but three components. We haven't worked with this, but hopefully it's obvious how and works. The only way for this statement to be true right here is if all three components are true. All three parts have to be true. So you would just go through the truth values, and it's very restrictive for a conjunction to be true. All three things have to be true. For example, if I tell you that I am I am drinking a glass of water and I'm on my cell phone and I'm watching TV, all three of those things have to be true. That's really hard, right? I'd have to do this and grab my remote control, right, in order for that to be true. You guys following that okay? Okay. All right, good. All right. In any case, as you work through this, on this particular problem, you're going to notice that you do not get a tautology, which means that this argument is not a valid argument. If someone were to make this argument to you out in public somewhere, you could say, hey, that's not a valid argument. And you could go through the truth table and show them why it's not valid. Okay. Oh, I'll skip over this. Should I do this? Let's see. Well, I'll just mention this. Are you guys familiar with Lewis Carroll? Have you heard of Alice in Wonderland?
Yes.
Okay. So the author of Alice in Wonderland is this guy named Lewis Carroll, and he was a mathematician and a logician. Um, if you watch the movie or read the book, Alice in Wonderland, or the other one, I think it's called Through the Looking Glass, do you notice that there's a lot of riddles in the movie and like the Cheshire Cat will say something backwards, or like the Mad Hatter would say something in a way that's hard to understand. Did you notice that when you watched the movie?
Yes.
Yeah, the reason for that is that Lewis Carroll is a logician. He studies what we're studying right now. And so what he wanted to do was to use some of his knowledge and put it into the movie where it makes your brain go crazy trying to understand what they're saying. But if you extract out the logic and put the symbols down, you can actually figure out exactly what they're trying to say. So I'm not going to go through this. I can't remember if I asked you anything I don't think I did, but if you're interested in going through this, you're fine. Um, uh, yeah, I don't think we need to go through that one. You just guys need the basic stuff. The reason they put this in is just because it's kind of interesting. Okay. I think that is it. Yep, that is it. Okay. All right, so I'm gonna stop recording and I'm gonna post this video in case anyone else wants to watch. Let me stop recording. How do I stop recording?